5, 6. There's no match. Only this tuple is match. So what we want is from the female employee, their dependent information. How can we get this tuple only? We can specify SSN is equal to ESSN for this. Okay? So this means Cartesian product is the all combination of R and S. Then if you wanna specify the matched one, we can combine with the condition. Like this. At that time, we called this operation as join operation. Have you ever heard about the join operation? What is a join? When we access data from two different relations, we need to combine both of them. Okay? How can we combine? First, Cartesian product. Cartesian product is all combination like this. But what we need is only the female employee who's dependent. Okay? Employee and their dependent. How can we check? With the condition. SSN should be the same as ESSN, independent. That is a condition of selection condition. So by combining selection condition and Cartesian product, the join operation is this one. Then relation name, two relation name with the condition. This is called join condition. How can we use the join condition? A join operation. For example, we have an employee table and department table. Employee table has only employee information. So like the employee name. Department table has only department information. Like the I want to retrieve first name and last name of department chair. How can you get the department chair information? First, we need to access department table. Does the department relation has the name of the chair? Yes? Only SSN. But we need. So how can we get such a data? I don't think we had let's see. Okay, here. So this is all combination of Cartesian product, department information and employee information. From the department, we can get only the manager social security number only. But we want get the first name, last name from employee. So any first name and last name? No. We need to check social security number is the same as manager social security number. So in other words, MGR SSN is equal to SSN. This is the join condition. So join is the operation with this symbol. I don't know the exact name of this one. It looks like the butterfly or sometimes a ribbon or whatever. Anyway, join operation between employee and department. Okay. So using this join operation, we can access the data from two different relations, two different tables. Okay? Very useful. However, you should be careful when you use the join operation. Why? It's a performance will be slow. It's a very expensive operation. Why?
Because all the data is
You need to access all combination. What if Department is 1 million. Employee, we have 1 million of employee. And department, the 1,000. Total, 1,000 million. Okay? Then you need to check the condition, then save in the temporary space, in the memory. Okay? So join operation is, even though it looks like a very convenient, yes, it's true. It's a very convenient way to access the data from multiple data sources. However, it's a very expensive operation. We will see later during the query optimization how much expensive and how to address. There is a way to reduce the such overhead in the join operation later. Okay. So this is the join operation of this one. To get the manager name, we need to combine two, department and employee. Combine means Cartesian product. Cartesian product is nothing but all combination. So if we have the 5 department and 10 employee, how many tuples will be created in Cartesian product?
25.
So 50, always times. Department has the 7 attribute. Employee has the 12 attribute. How many attribute after Cartesian product? It's a plus 90. Okay? Because we just combine all attribute of left hand side, all attribute of right hand side. That is the Cartesian product. Then join apply selection condition. This is called the join condition. Only the tuple that match it. Okay? Still join operation return all tuple. So I don't want to all tuple. Instead the manager name I name only. How can you get the name only? You can project like this one. So you can project and last name and first name or this. Okay. Another question. So now we can understand this join operation is one of the most important operation that differentiate from other database model. We have a hierarchical model, we have the network model, we have the object-oriented model. However, because of this one, still relational database model is one of the most popular and the top market share, the DBMS. It's very convenient way. Okay? And however, I have a question. What if employee exactly same thing, but only difference is order. Any difference between this one and this one? Yes? No?
Not in equation, not in natural judgments. If it's a right join or left join, then there is a difference.
There
In
is no
equation,
difference
it's
in
the
that.
same.
Yeah. So in terms of output, no difference, right? The only difference is the order of the attribute, okay? But as we have learned, the order of attribute is not important. So it's the same. In terms of the output, it's exactly the same. The only difference is
The
performance later. Why? Why performance is different? So think about it.
because like employee have like a million things.
We have the 10. We have 1 million. Okay? So think about we have the 10 parents. Okay? Long time ago, probably so also longer than 20 years ago, in my home country, I should serve for the government military. It's 2.5 years. It's compulsory. So all the men should join the army for 2.5 years. Okay, so most of the person actually quit their study during the college life, then they serve for the military, then go back to the university. And at the time in the military camp, after complete the initial training, most of the parents and visit to have a very short time meeting. So it's very So 1,000 of the new soldiers are in the camp, so we need to find them. So think about the 10 parents are in this room, and 1,000 the soldiers are there. So there are two ways. You can bring all 1,000 soldiers into this room to find the parents. Or parents can visit which one. Its performance are different, right? Even though final output is a 10 family will join, reunion, but its performance will be different. It's the same thing. So when we join the two tables, so for each department, if there is a way means actually index. To find the employee, how many times? Only 10 times. Check. And however, if we access the employee 1 million of time, you need to check. It's a huge performance difference. We will see details in the query processing and query optimization.
Professor, one question.
Yes.
The condition has to be always on the right-hand side.
That's just the syntax.
And those attributes belong to the employee relation or department relation?
Which this one? No. In this case, the notation is like this. I want to clarify just because it's not clear. This is the symbol, and R and S is the table and table. What? Relation and relation. And condition is a subscript over here, just like the selection condition, like the subscript. Okay. And one more question. What if the name of manager, attribute of manager is not MGR SSN, it's SSN. So which means condition is SSN is SSN. Is it a problem? Actually not a problem. So each attribute, each relation may have the same name of the attribute. But when you name your attribute, it's the best that because of that, why don't you try to do your best to represent the meaning of that attribute? Also, just in case if they are conflict, we can use what? Do you remember the R dot attribute notation?
Yes.
So you can use the department dot SSN, employee dot SSN to make sure. Yes.
In the condition, like we have to put some attributes, right?
Here,
Yes.
using attributes. yeah.
Exactly. So those attributes belong to the S relationship or the R relationship.
It can be one of them or both of them. But in case of join, it should be both of them from. You need to find the matched attribute. Okay? That is the reason most of the join condition comes from. Any idea? Foreign key, referential integrity. Okay? Why don't you go back to the relational schema diagram? How the two relations are connected using foreign key. Because of that, foreign key is very important. You can use, actually, according to the definition of join operation, you can join any of them. But it doesn't make sense. Only when you are using the foreign key, because manager social security number, refer the social security number. Because this data depends on this. Then we can use this condition as the join condition. Okay? But not always you can do the different attribute. But if your model design is perfect, only foreign key will be used for the join condition. Okay? That makes sense. Okay? What about D number is equal to last name? That doesn't make sense. No attribute will be returned. Okay? So that is the join operation. It's the most important operation in relational algebra and the relational model, relational DBMS system. Okay, so there are different types of the join. First, equijoin. As the name implies, is the equality. Equality condition here. This is an equijoin. Okay, you can use inequality. Then you can make, because this join operation always Cartesian product, then apply the selection condition. So as long as that tuple satisfied with the join condition, it will be written. However, it's not much used. Most of the case, equijoin will be used. Okay? And also, natural join is a very specific case, just in case, like this one. SSN, both two relation in case, just in case, two relation have the same name of attribute. Like the SSN here, SSN here. At that time, automatically join. Okay? That is naturally join. So because of that, natural join is not used practically, which means the Oracle, they don't use the natural join. And the Informix, they don't. Because instead, we would rather use the equality, equijoin. Okay? So natural join, but definition of the natural join is the in case common attribute from two relation. So automatically join. So for example, here, let's say we have the two relation. One is the project underbar department, another one is the department location. Can we find any common name of attribute? Location, manager, assistant, manager, and this one. We have the common name of attribute. It will be joined like this. Project underbar DPT join with the project underbar DPT dot MGR SSN is equal to DPT location dot MGR SSN then DEPT location. So instead of this one, we simplify this notation. So this is the symbol of the natural join. Natural join, in case we have the common attribute, we can automatically join, which is not used a lot. Okay, just to keep your mind. Okay, that's pretty much enough. Okay, that is the natural join. So, for example, natural join, the join operation can be represented by selection plus Cartesian product. Okay. Also, intersection can be represented by the union and minus. So, because of that, selection, projection, union, minus, and Cartesian products are fundamental operation. So, basic operation. Using this basic operation, we can imply, we can infer other operation like the intersection and the join operation. We can derive, we can make such operation. So these 5 operations are called complete set of operation. In other words, using these 5 operations, we can make any operation. Okay? So these are the basic operations used in here. And there is an additional operation such as a division. Division looks like a division in arithmetic operation. Like this one. But actually we cannot divide the table relation, right? So instead, division means we will use the example of this. So we have the SSN, the pianos. Actually this is from the SSN, from project relation. And Smith piano is a employee Smith. The project number where Smith is working. Okay? So there are 2 relations, 2 tables. Then division means we'd like to return all ESSN. Okay? That include the all piano. Numerator, denominator. Which means from the denominator, all that tuple that include all of denominator, which means from ESSN 1, 2, 3, 4, 5, 6, 7, 9. That include 1 and 2. So this is okay. Okay. Then 6, 6, 6, 8, 8, 4, 4, 4, 4. It has only 3. So this will not be returned. And 4, 5, 3, 4, 5, 3, 4, 5, 3, it has 1 and 2. So this is okay. Then 3, 3, 3, 4, 4, 5, 5, 5 has a 2, 3, 10, 20. There's no 1. So this will not be considered. And 9, 9. So later, all of this doesn't include 1 and 2. So this ESSN, this one and this one will be returned after division. Also attribute is from here minus this one, only ESSN. This is the definition of division in relational model only. It's not typical the division operation, only in the relational model. So once again, in the division operation in relational model means from nominator, we'd like to return the nominator that include all denominator. Okay? And then attribute is the minus, so which means ESSN only. Let's see the another example of this one. We'd like to do R divided by S, which means we'd like to return all A, okay? All A that include all denominator, which means A1, A2, A3. So it should be B, right? This minus this, so what about the B1? B1 is up to here. B1, does it include everything? Yes, A1, A2, A3. So B1 is okay. What about the B2? B2 has only A1 and A3. So this is not. And what about the B3? 2, 3, 4. There's no A1. What about the B4? A1, A2, A3. So B4 is okay. So output of R divided by S is B1 and B4. So output is B1 and B4. Good news, it's not used in current DBMS system. Current database, they don't use this one. Why? It's very expensive operation. You need to have the temporal space and check the each by each. So database, the DBMS, current DBMS system, they don't use. It's only offered the purpose in the when the relational model was proposed. Dr. E.F. Codd proposed this one, but it's not practically used. So just keep your mind what is the operation of the division. Instead, just in case we need, we can use other operation or application level. We can check. So these are the summary of the relational operation that we have covered, except the theta join. Don't worry about the theta join. Okay, so the other we covered. Okay, there are okay. So pretty much we have a time. The next thing is one of the very useful features when relational database model was proposed was it has very powerful statistical function. What is an example of the statistical function? Average, okay, and summation, standard deviation, or maximum, minimum. How can you get such a, how can you implement it? You need to read all the data and sorting the data and finally get the data. However, in database model, relational database model, the Dr. E.F. Codd already realized at the time many people want to use such a statistical function when they retrieve the data. So he proposed the relational expression, relational algebra expression that include such a statistical function, like the summation and maximum, minimum, and count. What else? Standard deviation. What? Average. Good. These statistical functions are implemented. However, as you can see, when you implement such a statistical function, what is the input of this?
Whole table.
Whole table or group of data, right? Relation. It's not record by record. How can you get sum? Sum of something group. Maximize data from the group. Minimum saying, counter saying, standard. All they require group of data. Because of that, this is called aggregate function. For example, average salary by department. For each department, we try to get the average salary. How can you get the average salary? First, you need to group. You need to group the employee by department. Then how can you group it? You need to sorting the data. First, sort the data. Okay, sort by department number, 1 through n. Then group, then apply such a aggregate function. So aggregate function requires such a grouping. Because of that, it's called the aggregate function. How can you use? Two operation. This is a symbol of the aggregate function. Okay. Then grouping factor. This is a grouping factor, and this is the aggregate function. For example, for each group from the employee, per average salary per department. How can we represent? Input is employee, and output is the grouping factor. Group by what? Dn. Then what do you want? Average salary. Okay. So this is the notation. What about the maximum salary? Highest salary? You can use the maximum. What about the number of employee per department? How can you do that? Department count. Count what? Salary? SSN is the best. Why? SSN is the key. So it's not definitely duplicated. So SSN. So these are the example of using the aggregate function. Left hand side, the grouping factor. Right hand side, the aggregate function. You can use the 2 or more aggregate function. No problem if you want. And it will be like this. If you want to rename it, you can use the row operation to rename the output of the data. So this is the DNO. I forgot to. These are the subscript. What about this one? Last one. There is a missing part, left hand side, right? Only aggregate function. What does that mean?
All the
Yes, all the data. We consider all employee as a group, which means how many employees in this company and what is the total average salary. Okay, so at that time you don't have to specify. If you consider all input as the group, you don't have to specify the grouping factor, but that is still aggregate function. So left hand side grouping factor, right hand side the aggregate function. Okay. Recursive means I try to list the supervisor, and his or her supervisor name, name plus supervisor name. Which means, so Lee supervised the pattern, Lee supervised the James, Lee supervised the John, and also pattern supervised the Sean, and so on. Okay? supervisor name, supervisor name. Where can you get the supervisor name? Employee. Where can you get the supervisor name?
Student table.
Student table? Employee. Both of them are employees from the company database. Okay? So, which means, do we need to access only one table? We need to still access the two tables, but actually that are in the same table. At that time, it's called the recursive operation. Recursive closure. So, how can we get this data? So, supervisor, SSN should be the same as SSN, right? This is a condition. From where? Employee and employee. You can join employee and employee. Same table, but we consider one is for supervisor employee, another one is for supervising employee. Okay, that is called a recursive. So also that will be implemented in the SQL. We will see later. Okay. In SQL 3 standard, we will see what is the SQL 3 standard later. It's the level of the standard, history of the standard of the SQL, but they actually it's standardized for the recursive close, like the to print out, to retrieve the data as a tree structure. One, because Lee supervised the Potter, and also Potter supervised the James. It's a kind of a tree structure. So you can retrieve such a way in SQL 3. So this is the example of that. The next thing is the little bit advanced one, but it's not very complicated. Outer join. Outer join means, for example, here. Is it the Wednesday? So we have class on. So outer join means SSN and DN. 1, 2, 3, 4. And DN is the 1, 2, 3, 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4. And none. DPT, DNUM is 1, 2, 3, 4. And name is HR, admin, payroll, and the external affairs. Then we have 4 departments. We'd like to join with the DNO and D number. So employee join with the DPT. DNO is equal to DNUM. How many tuples will be returned? Only 3. This is a match, this is a match, this is